Hey class, so we're here with your start to Chapter 8, and Chapter 8 is all about proportional reasoning. So this is going to be the first lesson, this is going to be the 8.1 lesson, but what you're going to learn throughout 8.1 all the way to 8.6 is you're going to be able to develop your spatial sense and proportional reasoning by solving problems that involve rates, solving problems that involve scale diagrams, and determining the relationships among scale factors, surface areas, and volumes of similar objects, and you're going to use these relationships to solve problems. So we're going to jump right in and try and keep this video short. In 8.1, really the learning target for us is to represent, interpret, and compare rates. So before we do that, we have to understand two key terms, what a rate is and what a unit rate is. So a rate, which most of you are familiar with, is a comparison of two amounts that are measured in different units. So for example, you could say someone types or keys 240 words per 8 minutes. One thing that you have to understand is that this slash is representing the number per, but equally that this is just giving you a ratio. And so what most people don't understand is that this is actually a fraction or a ratio that could easily be written also like this. I think this is probably just came out of convention of having to type rates in papers, and so no one ever wanted to go and insert a fraction, so they basically adopted this notation. But really this is the same as, these two things are equivalents. Okay, and we can see the division here, whereas we don't necessarily see the division in this part. Now, a unit rate is a rate in which the numerical value of the second term is 1. For example, keying 240 words per 8 minutes could be expressed as a unit rate of 30 words per minute, and that's where we would have the 30 words over 1 minute. And so it's just the idea that your denominator is 1, so when you do your division out, you're not changing your numerator. So essentially getting a denominator of 1, you have a unit rate, and that often makes it really easy to compare things. So let's jump right in and compare something. So here we have a situation where a runner ran a triathlon, or I shouldn't say run, I guess, it's triathlon, but it consists of 3 different races. There was a 1.5 kilometer swim, there was a 40 kilometer bike ride, and a 10 kilometer run. The time it takes to transition from one race to the next is given as the trans in the official records, and the setup for the transition area is different in different triathlons. Simon Whitfield of Victoria, British Columbia, participated in the triathlon in both the 2000 and the 2008 Olympic Games, and his results are shown in the tables below. So we're looking at this, and the question would be, how can you compare Simon's speeds in his 2 Olympic medal-winning triathlons? So I think he got, you can see he got a gold medal here, and a silver medal here. So how can we compare his speeds? Now, one important thing is that I would hope that when you see the word speed, you already start thinking of, hey, that's referring to a rate. And so probably since we're dealing with 2 separate quantities here, we're dealing with distances of 1.5 kilometers, 40 kilometers, and 10 kilometers. And what's being presented in the table are a bunch of times. So that's where we're going to get our speed from, remembering that speed is simply distance over time without direction. So how could we compare this? Well, for starters, I'm going to ignore the trans times. We're going to get rid of those, and we're just going to look at comparing his speed over each leg of the trip. So the easiest way to do this would be to find a way to convert them to a unit rate. Now, I'm going to use a little bit of a different notation here. So what I'm going to do is I'm going to write speed 1, comma 1. I'm using those as subscripts. And what that's going to indicate is that this was his first attempt, and it was the first leg of his trip. So if you think about speed is the change in distance over the change in time, and speed doesn't care about direction. If you start caring about direction, you're actually talking about velocity. But we are interested in the speed. So what was his change in distance? Well, his change in distance, remember that the swimming portion was 1.5 kilometers. The cycling portion was 40 kilometers. And the running portion was 10 kilometers. So those distances are never going to change. So what was the distance covered in that first leg of his trip? Well, it was 1.5 kilometers. Now the trick becomes trying to set up the bottom part. We're interested in the change of time, but it's being given to us in both minutes and seconds. So what I need to do is I need to find a way to convert this number to 1 unit. So if you think about it, 17 minutes plus 57 seconds is really 17 minutes plus 57 sixtieths of a minute. So all I'm going to do is I'm going to do this calculation on my calculator. So I'm taking 17 and I'm adding to that 57 60ths, and I'm getting back 17.95. So that's the same as saying 17.95 minutes. So there becomes my bottom quantity. I've got 17.95. Now this technically is a rate at this point, but I think it would be easier for us to compare them if we use the unit rate. So I'm going to take 1.5 and I'm going to divide it by 17.95. And in doing that, I get back 0.0836 is what it rounds to. So 0.0836, and that is kilometers per minute. So you can see now I have a unit rate, and I got that by doing 1.5 divided by 17.95. So what I want to compare to that is his second run first leg. So the change in distance is going to be the same. They still had to cover 1.5 kilometers. So if I put in my 1.5 kilometers, then again, how do I get my minutes? Well, now I'm going to try and figure out what 18 plus 18/60ths is. So I'll do 18 plus 18 over 60, and that gives me 18.3. So now I found out that this is 18.3 minutes. And so again, I'm going to convert this to a unit rate. So I'm going to take 1.5 divided by 18.3, and I'm going to get back 0.081, and it actually would round to 0.0820. So 0.82, oh, I missed a zero. So 0.0820 kilometers per minute. So if you look at this and you say, well, which one was actually faster? This number is larger, and so in the blue, his first time was actually faster, which kind of makes sense to us if we look at the total times. We're expecting him to be faster in the first leg. Just to make sure you're solid with this, I want to do one more example. So I'm going to do his first trial, or his first run, his second leg of his trip. So the change in distance this time, because we're cycling, is 40 kilometers. His change in time is 58 and 54 60ths. So 58 plus 54 out of 60, and that gives me 58.9. So he did this in 58.9 minutes. Again, expressing that as a unit rate, we would take 40 divided by 58.9, and that gives me 0.6791. So 0.6791, and that is kilometers per minute. So if I look at his second attempt in his second leg of his trip, again it would be 40 kilometers. And now I need to figure out what 58 minutes and 56 seconds are. So I'm doing 58 plus 56 divided by 60. And that gives me back 58.93 repeating. So 58.9333. I'll stop at, taking 4 decimals. And now I'll find my unit rate by doing 40 divided by 58.9333. And I get back 0.6787. So that's 0.6787. And so again, if we compare those two unit rates, you'll notice that the 9.1 is higher than the 8.7. So he was faster in the first time. Okay, so I think you can see how you could do that for the last leg. So what I want to take a second to do now is look at how we might do this graphically. Now, this is simply just a representation. This is not to scale. If you wanted this to have real value, you would have to try and do this perfectly to scale. But I'm just outlining the procedure of how you might use a graph to help you view this. So what we'll do is we'll try and plot our points. So we know that both of them are starting at 0. Now you'll notice I have a distance axis and I have a time axis, and I've indicated some key points on my time axis. And these arrows on the left hand side, you would never put them in, but I just wanted you to understand that I'm assuming this distance is the 1.5 kilometers, this is the next 40, and this is the next 10. So these are just representing the 3 legs of the race. So if you look at his first time, he was basically just under 18 minutes. So I'm going to go ahead and put a point just under 18 minutes, and we'll look at that slope. So that's how long it took him to get to that particular distance, to finish that first leg. Now, his next one, if you add these two together, you get very close to 77, but you're just under it. So again, here's my 77. I'm just going to go just under that 77. Again, the more accurate your graph, the better that this would be displayed. And you should be using a ruler to try and draw straight lines. If you now add on the extra, basically 31 minutes, you come just below 108. So just below 108, somewhere around here. And all of a sudden you'd get this. Now if we try and do this for the second leg, you'll notice that his time was actually a little bit over 18. So I'm going to go over 18. And the next one is a little bit over 77. So all of a sudden it's over 77. And the next one's a little bit over 108. So it might be hard to tell from this graph, but what I'm hoping you can see is that the slopes of his first run, or the one displayed kind of in this pinkish purple, are a little bit steeper than the ones displayed in his second kind of go at it. So that would tell us, you know what, he was moving faster consistently through all three legs in his first trial. And so basically what I wanted to take from this lesson is that you can compare things using unit rates, or graphs.